Hello, and welcome to another Orange Coast College mathematics video. In this video, we're going to do an overview of factoring. That is, I'm going to assume that you are familiar with all of the different factoring techniques. And our goal here is when we're presented with a polynomial that we need to factor, but we're not sure which technique to use, how we can determine which technique to use and then to factor it. All right, our first step when presented with a polynomial we need to factor will be to factor out the greatest common factor. So we should check all of the terms for common factors and then pull out the greatest common factor. That will leave us with a monomial times a polynomial which has more than one term. Okay, the number of terms will be really useful in determining which technique to use. So if your leftover polynomial has two terms, then it is likely a difference of squares, a difference of cubes, or possibly a sum of cubes. Now, it's possible it can't be factored at all, and that's okay. All right. If it has three terms, then it may be a quadratic trinomial of the form ax squared plus bx plus c, where the coefficient of x squared is 1 here. Or it may be ax squared plus bx plus c, where that a is not 1. We call these quadratic trinomials. It could also be a perfect square trinomial. Okay. Finally, if it has four terms, you will generally factor that by grouping. Now, it is possible that it is not factorable, and that's okay. Once you've used the correct technique, okay, you may have to factor again. So once you've factored that polynomial, there may be more things that you can factor. Make sure every polynomial factor you end up with is completely factored. Remember, you cannot factor a sum of squares. So like x squared plus 4 cannot be factored. Finally, check. Multiply it all back out if you want. See, do you end up with what you started with? Here's our first example. All right, we want to factor this polynomial completely. So our first step, factoring out the greatest common factor. If we look amongst all of the terms, the largest integer that divides all of the numerical factors, 30, negative 30, 24, negative 24, will be 6. Okay, and amongst all the variable factors, we have A's and B's here. The greatest common factor between those will be A times B, because we have only one factor of B here and only one factor of A here. So we can factor out the GCF, which is 6AB. Once we've done that, what will we have left over? In the first term, we will have 5AB. The second term will be 5A. The third term will be 4B. And the final term will be negative 4. All right. As I said in the steps, we now have this greatest common factor times this remaining polynomial. And this remaining polynomial has 4 terms, so we think, can we factor this by grouping? And if we pair off the terms as written, then what we'll do is we'll factor out the GCF from each pair of terms. So we will have 6AB times, from the first pair of terms, our greatest common factor is 5A. We factor that out. We will have left over B minus 1. From the second pair of terms, our greatest common factor is 4. We factor out the 4, we will have left over B minus 1. And now we have, in these two terms in the brackets, we have this common factor of B minus 1. Factor that out, and we have 6AB times B minus 1, and then left over, we would have 5A plus 4. And again, don't forget to check, are each of your polynomial factors completely factored? And in this case, they are. And then if you feel like it, check your work. Okay, example 2. So we first have this a polynomial. We check, do we have common factors? And we do. Each term is divisible by 5, and each term has a common factor of x and y. So we can factor out the greatest common factor of 5xy, and then we'll have left over, we'll have 9x squared minus 12x plus 4. Okay, so what we're left with here is a quadratic trinomial. Okay, now you could use the method for quadratic trinomials when we have ax squared plus bx plus c, where a is not 1. In this case, the coefficient of x squared, is 9. But we notice here 9x squared is 3x quantity squared, and 4 is 2 squared. So we wonder, do we have a perfect square trinomial? And it turns out that we do, because this is 3x quantity squared. This is 2 squared. And this middle term, negative 12x, can be written as negative 2 times this guy, 2 times 3x. So this fits the formula a squared minus 2ab plus b squared. So we can factor it using the formula for perfect square trinomials. It will just be 5xy times 3x minus 2 squared. And that's it. Check your work, multiply it back out, ask, do we end up back here? Okay, on to example 3. We first start by factoring out the GCF. So for these 3 terms, we see that each term is divisible by 3, and each term has a common factor of x squared. So we can simply pull out 3x squared, and then left over we will have x squared minus 3x minus 10. So our remaining polynomial here is a quadratic trinomial of the form x squared plus bx plus c. So the coefficient of x squared is 1. So what we do, we write 3x squared. I'm going to draw my parentheses here. We have an x goes here, x goes here. Now, what do we put in the blanks? We look for 2 numbers that multiply together to give me negative 10 and add together to give me negative 3. So the 2 numbers that will fit that will be negative 5 and positive 2. And that's what goes in those blanks. So negative 5 and positive 2. Because when I multiply out negative 5 times positive 2, I get negative 10. Add them together, you get negative 3. And that's it. This is factored completely. We're done. Check your work. See, do you end up with what you started? Okay, example 4. Again, first step, factor out the greatest common factor. So each term is divisible by 2. Each term has a common factor of x. So we factor out 2x. We will be left with 12x squared minus 17x minus 5. All right, so now we have our remaining polynomial is a quadratic trinomial. So it's ax squared plus bx plus c, but our a, our coefficient of x squared, is no longer 1. So we're going to use what we call the AC method. So I'm just going to write down real quick. This is a, b, and c. So a times c is 12 times negative 5 is negative 60, and b is negative 17. So we are looking for 2 numbers, okay, that multiply to negative 60 and add to negative 17. And the 2 numbers that will work are negative 20 and positive 3. So what we do, we rewrite our quadratic trinomial as the same thing, 12x squared, but what we do is we break negative 17 into a sum of negative 20 plus 3. So we write negative 17x as negative 20x plus 3x, and then we leave the negative 5 there alone. And now we factor by grouping. So we have 4 terms, we pair them off, and from each pair we will factor out the greatest common factor. So we have left over here 2x. From the first pair, we can factor out a 4x. So if we do that, we'll have left over 3x minus 5. From the second pair, the GCF is 1. I'm going to factor out the 1 just to be explicit here. So we'll have 1 times 3x minus 5. Okay, so for the polynomial in the brackets, each term has a common factor of 3x minus 5. So now factor out the 3x minus 5. We're left with, we have 2x times 3x minus 5. And then left over from each term, we would have 4x plus 1. Okay, and that is factored completely. Each factor here is completely factored. All right, check your work. Do you end up back where you started? Example 5. All right, we have 2 terms here. Our first step is to factor out the greatest common factor. So each term is divisible by 3, and each term has a common factor of a squared. So we factor out 3a squared. We will have left over a to the 4th minus 16. Now we have a binomial here, so it's 2 terms. So our first thought should be difference of squares or difference of cubes. And what we have is a difference of squares. A to the fourth is a squared squared. So I'm going to write each term as a square. So 3a squared times a squared quantity squared, and 16 is 4 squared. Okay, now use the difference of squares formula. So it's going to be 3a squared times a squared minus 4 times a squared plus 4. Okay, however, we're not done. This a squared minus 4 is also a difference of squares, right? It's a squared minus 2 squared. Now the sum of squares, this cannot be factored. But we can factor that difference of squares. So we have 3a squared, and then a squared minus 4 will factor into a minus 2 times a plus 2, and then we still have a squared plus 4. And now we have factored it completely. Okay, check your work, and we're done. Example 6. We start by factoring the greatest common factor from these two terms. All right, each term is divisible by 2, and each term has a common factor of y. So we start by factoring out the GCF, 2y. Left over, we will have 8x cubed plus 27y cubed. Now we have two terms, so again, think difference or think sum of cubes, right? We don't have sum of squares, so that's what you should be thinking. Each term is in fact a perfect cube because 8 is 2 cubed, 27 is 3 cubed. So I'm going to rewrite each term as a perfect cube. The first term will be 2x quantity cubed. The second term will be 3y quantity cubed. All right, and then we simply need to use the sum of cubes factoring formula. So this becomes 2y times 2x plus 3y, and then it'll be the first term here, 2x squared. So don't forget to square the whole thing, not just the x. Then it will be minus the product of these two terms. So it's going to be 2x times 3y. Remember, because this sign and this sign here should be the opposite. And then finally, it will be plus the square of this second term, 3y. So we have 3y squared. The last step is to just simplify. So we have 2y times 2x plus 3y times 2x squared is 4x. Negative 2x times 3y is negative 6xy. Sorry, this should be 4x squared. And then finally, the last term will be 9y squared. And this is factored completely. This trinomial that you end up with here will be unable to factor it. Okay, you can multiply this back out, check your work. Okay, on to our final example, example 7. We start by factoring out the GCF. Now, if we look at each term, there's a common factor of x amongst all three terms, and each term is divisible by 5. Okay, so we can factor out the GCF, which is 5x. Left over, we will have x to the fourth minus 13x squared plus 36. Now you look at this, it's a trinomial, but it is not quadratic. We have a fourth degree term here, x to the fourth. So it's not a quadratic trinomial, but it is what we call quadratic in form. And that is because the variable is x, but you can think of this first term as being x squared squared. And then the second term, instead of having an x, we have an x squared. So if you think about the variable as being x squared, this would be quadratic in that variable. If this doesn't make a lot of sense, the idea here, again, we have x squared squared. And I'm going to rewrite this as 5x times x squared squared minus 13x squared plus 36. If you think about x squared as being a new variable like z, this would be z squared minus 13z plus 36. That would just be a quadratic trinomial. And so how do we factor it? It's a quadratic trinomial in that variable x squared with the coefficient of the squared variable is 1. So we're just looking for, we put our x squareds in here, we're looking for two numbers that multiply together to give me 36 and add together to give me negative 13. That's what we'll fill in these blanks. So the two numbers that fit that bill would be -9 and -4. All right, -9 times -4 will give me +36, but -9 plus -4 will give me -13. Now, we're not quite done because both of these binomial factors are a difference of squares. This is x squared minus 3 squared and x squared minus 4 squared, or 2 squared, sorry. So to each, we apply the difference of squares formula, factoring formula, and we get 5x times x minus 3 times x plus 3. That's the first. And the second one will be x minus 2 times x plus 2. And that's it. Feel free to check your work. And that's an overview of factoring. It's very important to practice these techniques and to do as many repetitions of this as possible. You need to develop an intuition for which technique to use and comfort in using each individual technique. Okay? If you practice this a lot, at some point it will become second nature to you. All right. Until next time, keep practicing. Have fun.